identities. So when I tell you for a test to study identities, I'll usually tell you it's the left-hand, right-hand side sides. But in them, the actual two identities that you should know is that tan is equal to sin over cos and sin squared plus cos squared equals equal to 1, which is an equation that you can shuffle about to make whatever there is true. So your question is, when you start off with left-hand side, right-hand side, what was the question? Prove that this is equal to that. So you shouldn't even start off writing it equal to each other, because then you will want to, in an equation, start taking stuff across from each other. Alright, so one or two of you came to me yesterday, and I helped you with it, because it's a small sum you can see. Because the first thing I taught you was golden rules, always take it to sin and cos. Done. If there are fractions, there's no fractions, then when you add your LCD, okay. What else is there to do to simplification? Factorize. Factorize is part of your math air that you breathe. So can you factorize this?
No.
Yes. Can you factorize this?
Yes.
You can. It is the
Difference
of squares. But would you factorize it?
No.
Remember, I'm trying to get them the same.
Yes.
This one's much bigger than that one. So breaking down this smaller one even more is going to not get me to this one. Sure. You're figuring out, it's possible to factorize, but I don't, because I'm sorting out what will be useful and fruitful. So in this one, it's also the difference of squares. It's like A4 minus B4 in algebra, which you know will then be the difference of squares. A squared times A squared, B squared times B squared, one with a minus, one with a plus. Are you with me? And then this one can go further. That's the algebra part. Now we're getting to this one. Even if it's sin, we're treating this sin as if it's A, as if the whole sin x is the variable. So what times what gives me sin to the 4? Sin squared times sin square, and make sure that you've got the square, that you've got the x, that you don't lose a few stuff along the line. And the same with cos. It's going to be cos square times cos square. And one must be a minus and one must be a plus, and it doesn't matter which one, right?
Yes.
And then what?
Identity.
Yes, the identity. That one is equal to 1. And please show the markers that you're seeing that it's 1. And can this one now still factorize? Yes, but why would you want to? Your mission was to get them the same. So even if the left-hand side has got 6 terms with fractions and all sorts of stuff, and the right-hand side has got those same 6 terms with the same fractions and roots and whatever, and they're the same, you don't have to simplify. You just have to get them the same. So your answer is finished. How many marks for this sum? 2. Because it'll be for factorization. And then for noting that this was equal to, because it didn't happen in algebra, because there's no trig relationship between A and B. That I know for a fact when I graph out sin squared plus cos squared, it will always be 1. Sin plus cos, is that 1? No, it has to be square. It's a square identity. Alright, so that question was worth 2 marks. So basically I had to figure out that you know that that was going to become 1, that's why they're the same. Next one. Golden rule?
Everything must be sin.
Sin and cos. So everybody's going to get a mark for this sum, because there was a tan, but you're going to change it to sin over cos. Well, there's actually 2 of them, but you're not going to get 2 marks for doing it twice. Somewhere along the line, you're going to get a mark for saying that tan is sin over cos. Are you with me? And are there going to be alternatives?
Yeah.
Always in maths. Maybe your alternative is a little bit longer. My alternative is a little bit longer because I didn't see your shortcut, and then I'm going to say, oh wow, great. Because there's always a variation. Okay, so if I change everything to sin and cos, that's fantastic. Sorry. But I didn't have to change it to sin and cos, but I'm going to anyway. Okay? We're going to change this into sin square times
Over cos square.
alright, which will then do what? Now I'm in fractions, right? And this I can simplify a little bit because it's going to become sin to the power 4. Just like in algebra, when you time sin squared times sin squared is sin to the power 4. This was still standing here doing nothing over 1. And the LCD will be cos squared. And at the bottom you timed with cos squared to get to the LCD. So the top must be timed with cos squared again. So you're going to have sin squared, cos squared. And this one was timed with nothing, so it's just sin to the power 4. I'm going to show you the alternative now, and you're going to see how short it actually can be if you had seen something. Alright, but if you keep to the golden rules, you'll always have something to work with. You've got a tool to use. But what now? Because I want to cancel these things out, and somewhere I want the tan to pop out. Because I know I want it to be sin square over cos square if I don't change it back to tan. I know that that's what I want. So I need things to cancel out. So this is a problem.
Yes.
How do we solve this problem of having a plus? Factorizing. Factorizing. How can I factorize that? You take out a common sin square. So if you take out the common sin square, what's left? Cos square. And you take out sin square there. Plus sin square. Are you seeing it? What's that going to be? That's going to be 1. Good idea. Highlight it on your paper. Write to the person marking that it's equal to 1. Because now I'm actually finished with my sum. I just need to round it off a little bit and show them that this is then tan square. If I did write it here. If I wrote it as sin square over cos square, leave it sin square over cos square. I'm trying to get them to be the same. So tan square, and what about that? I just want to show the guys I know what I'm doing. So that little PC there was 1. Left hand side is equal to the right hand side. Now let me show you what other trick I want to teach you if you want to use it. Couldn't I have factorized from the start and said take out a common sin square? Then what would be left? 1 plus tan square. You still have to go with your tan, and you have to go and get LCD and fractors. I'm just trying to show you you can think a little bit differently. Okay, golden rules. Take everything to sin and cos. If there are fractions, do LCD. If possible, factorize. And those are not the only rules. You'll see some manipulations here and there. Level 2 at least for left hand side, right hand side. The nature of the sum is not level 1. Okay, happiness? Right, number G, the last one I gave you for homework. So we're saying you are going to distribute it. It's absolutely right, but I want you also to do sin over cos. So if you first want to distribute and say cos tan, and then write tan as sin over cos, it's fine. If you first want to write tan as sin over cos and then distribute it, it's fine. So I'm going to leave it as cos, just for no reason particularly. But Mam says, the moment I have used the sin over cos, I should have a mark. Even if I don't get anywhere with a sum, to get them remotely equal to each other, I've got the sin over cos, I'm sure Mam's going to give me a mark. Because it's worth a mark, because I'm testing these identities. Then if I now distribute, what is going to happen? I'm going to have cos theta. And when I time cos theta with sin over cos theta, it's just sin. You see it? Because that cos is over 1. And when you time it with a fraction, the cos at the top and the cos at the bottom are going to cancel out. And you're going to be left with plus. Done. You with me? Golden rules, tan becomes sin over cos. Now, if you had distributed first, then made the tan sin over cos, it would have come to exactly the same answer. So it would have been a mark for sin over cos and a mark for the distributive law. 2 marks again. Then this is definitely just level 2. I want to say it's almost level 1, but normally left-hand side, right-hand side falls under level 2. Are you all on board? Yeah. Do you realize that we need lots more exercises?
Yes.
All right, let me do one more example for you. One more example, and there's your homework there. So, out of the nature of the sum, some of them are more difficult than others. Higher levels and smaller levels. So, is the fact that I've always got to go for sin and cos relevant for the sum? It's in any case sin and cos. Have you seen this?
Yes.
Usually you don't want to work on both sides. I don't think I've said it to you before. If you work on both sides and do all sorts of stuff on the left and on the right hand side, you will find that if you make a mistake, you're going to tend to make the same mistake one direction on the left hand and in the other direction on the right hand side, and you're going to find them equal to each other because you made the same mistake just in different directions. It makes kind of sense. So it's a good idea to try and just work on one side, but that's not a golden rule. You have to only work on one side. You can. So if you want to work on both sides and get a larger elaborate thing on the right and the same thing on the left, and it's correct, 4 marks, no problem. This is not about simplification, it's about getting them the same. Because if I really had to, can I do something on the right hand side? Right. There's no simplification now. What fact have you got? That sin square can be substituted with 1 minus cos square. Where does that come from? Because sin square plus cos square is 1. I'm talking in the air because I want you to know it in your mind. Sin square plus cos square is 1. So therefore sin square alone is 1 minus cos square. So if you wanted to do that and write 1 minus cos square here, and you show me something on this side remotely, there will be various memos. The memos in the matric end exam. Sometimes for one question it's like 4 or 5 pages. Alternative, 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 and then on day 4 of marking, some clever kid does something miraculous and everybody's excited on it and they add another alternative to it. Because there's various ways of doing stuff. Are you with me? So, if you wanted to start on the left, because now what am I going to do here?
Nothing. Oh, that's difference of squares.
Difference of squares. 1 minus theta, 1 plus theta. So now I don't know what to do here, so I'm going to do it there. So if I do 1 minus cos, 1 plus cos, and then what? And then we time it all out again. Okay? But now really I'm out of ideas. Let's go to the left hand side. Take everything to sin and cos. It's already sin and cos, it's just cos. But it is fractions. So let's get the LCD. Of these two denominators, what is the LCD? That whole bracket and that whole bracket. And at the top? What did you time at the bottom?
1 plus cos
That
theta.
bracket.
Yes.
So that 1 must be timed with 1 plus cos theta. It's not necessary for the brackets, but it's safe. Then plus 1 must be timed with 1 minus cos.
theta.
Right? If you take away all the brackets, like timing them out, do I time out the bottom?
No.
No, you want these things to cancel out and simplify. So before you just start timing out, just wait a while. Maybe at the end you're going to time it out, but for now we're trying to see if something can cancel out. What happens at the top? You have like terms. So we've got cos theta minus cos theta is 0. And 1 plus 1 is 2 over. Now if I had done what I had done on the right hand side, I would have kept it like this, because now I can just say then left hand side is equal to the right hand side. If I didn't touch the right hand side, what then? Then you should have timed this out to get to 1 minus cos. How come? Because the brackets are the same. Do you see the lots of algebra? The brackets are the same except for the plus and the minus. So when you FOIL, the minus cos and the plus cos fall away. And 1 times 1 is 1. Minus cos times plus cos is minus cos squared. And then this is the identity. So the kid that did the other one got the identity mark here. This kid is going to get the identity mark for knowing that 1 minus cos squared is sin squared. For making the connection that answer is equal. So you see lots and lots and lots of different variations that you can use. I like it to just touch the one side, especially for kids, because we do have that problem. If we make a mistake on order of operations, you tend to do it twice. Once in one direction and one in the other direction. And then you think you're right, but actually the sum is incorrect. Last thing, not worth a mark, right? I say, man, you asked me to prove it, I did prove it. Okay, so your homework sums are 2 more of those, left hand side, right hand side, and then back to the older ones, which were just the reduction formulas. Because we've got to get through the stuff, but I still think, I know that you still need a lot of exercises. Okay.